Fine, ma'am. How are you?
I am also good, Rashid. So how the studies are going on?
Good, ma'am.
Okay, great.
I'm on final exams. Like they start from 13th March.
From 13th March.
Yes, ma'am.
Okay. Still, I think almost some 10 to 12 days are there.
Ma'am, in science we just only have 4 chapters.
Only 4?
Yes, ma'am.
Oh.
They are like electricity circuits, magnets, light shadow reflection, and air.
Okay, it's like easy then in that case.
Yes, ma'am. So our ma'am told that she'll be repeating the revision twice, like thrice.
Right, because so much of time will be there, right?
Yes,
So then
ma'am.
what to do?
And it will be like a good practice.
Correct. Good evening, Adrit. How are you?
Fine, ma'am. How are you?
I am also good. So Adrit, you dance so well. Yes, Adrit. You know how to dance, right?
Yes, ma'am.
Great. Rashid, do you know how to dance?
Yes, ma'am.
Okay. But I don't know how to dance. Okay, children, now turn on your video. So, as discussed in the last class, we will be uh, starting now revising the new chapter. And Adrit, I think fun with magnets, right? We need to revise?
Yes,
Yes,
ma'am.
ma'am.
Okay. Rishit, you also can turn on your video?
Okay.
Okay, thank you. So last time we have discussed the chapter light, shadows, and reflection. So we have discussed the light, the different types of the lights, like the reflections, the irregular, regular. Then shadows, how does the shadows form? Transparent, translucent, all those opaque things we have discussed.
Yes.
And then reflection also we have discussed about the different radiations, rays, violet, indigo, all those colors we have discussed. So now today we'll be starting with a new chapter to revise, which is the fun with magnet.
Yes.
So I hope like both of you are aware of the story, right? So how the magnet was formed by
Yes, ma'am.
by a boy, right? So it was
By
formed by
shepherd.
a boy. Yeah, shepherd. So he was the one who like discovered this magnet, and on his name only it was given as the
Magnus.
magnet, right? What was his name?
Magnus.
Magnus. So his because of his name, this name was given as the magnet. So I hope both of you have seen the magnet, right? So in
Yes.
our day-to-day life, maybe in the the TVs, earlier in the TVs we used to have the big magnets, but now what is happening as the technology is improving, the size of the TV as well as the size of the materials which are required for that is also decreasing. Now we cannot see easily where the magnets are, right? But earlier it was like big magnets used to be there at the back of the TV, behind the TV, and then if maybe by a chance like TV get not working, then in that case what we do, we just take out the magnet and we used to just play with the magnet. But now we cannot do that, right? It's not easy. And earlier you might have seen the TVs, like how the TVs were there, like with the open and shut doors were there, and like that it was used to work, right, it's just like this, like opening and like this closing. So it was like that during like so many years back. But now very slim TV we are getting, like the laptops also, like laptops we are getting slim instead of earlier we used to have the desktop, like big the very big size and all, we cannot move also much them. So it's like about the advancement of the technology we are getting, and because of that, this is like happening. Now, how many poles do we have? The
Two.
magnets have how many? Okay. What are those? What are
North and
those two
south.
poles? North and south. So what are the two main properties of them? So same poles will be
Repel.
repelling each other, and the opposite pole will be
Attract.
attracting. So this is are the like major point about the magnet, that if the same poles are there, they will never come close to each other. They will always be repelling matlab moving
Yes.
apart from each other. Whereas when we talk about the different poles, they always attract to each other, right?
Poles
So
repel and unlike poles attract.
yes, correct. So the like poles will be repelling and like poles will be attracting. Now what happens if in case I had the magnet in my hand, by mistakenly I have like made it fall down, so will it break?
Yes, like if the magnet is too strong, it may not. But if it's like weak, it will break.
It will break. Okay, in that case, Adrit, what happened if the magnet gets break by mistakenly? Then what happened? Will it act as a
Like,
magnet?
no, ma'am, like it's attracting energy goes.
So you are saying it will not attract the magnet, so it will not work as a magnet now.
Yes, ma'am.
What about
No.
Rishit? Will it work as a
Yes, ma'am,
magnet
it
now?
will work.
It will work, Adrit. It will work. Okay. So see what happened. The only difference will be like, okay, I had a magnet by mistakenly it what broke down. What
So it will
happened?
become into
The
two
power,
pieces.
yeah, the power of the magnet will reduce, but the magnetism will be there. So if I have a big one magnet, it has good evening, Anu. So if I have a big magnet, the magnetism will be more. But if the several pieces of that magnets are there, the magnetism will decrease, but it will work as a magnet only. Okay.
Ma'am,
And
and the parts like if there are two parts, those two parts have same two poles again, north and south.
correct. So what happens now? Anu, we are doing the next chapter, which is revising the next chapter, which is fun with magnet. So then what happened now? If I got five pieces from that one piece, then what happened? All those five pieces will have the North Pole, South Pole, North Pole, South Pole. Okay, understood, Adrit? This is very important for your higher grade also. Okay, so if it is broken down, that's okay, but certainly the magnetism will reduce, and all the broken pieces of the magnet will have what? The north and the south pole.
Yes.
So now the north and south pole will be there for each and every broken part of the magnet. All right. So let's start now. This was a basic idea of the whole chapter. So let us start with the detailed version of it. Okay, fun with magnets. At the end of the lesson, we will be able to determine which object are magnetic and which are non-magnetic. So basically, which object are magnetic, they are called as a magnetic material, and which object are not magnetic, they are known as a
Non-magnetic material.
non-magnetic material. So if I have the pencil is magnetic, non-magnetic.
Magnetic.
Pencil is magnetic,
I'm like a pencil's lid is magnetic.
I spoke about the pencil, not about the lid of it.
Ma'am, non-magnetic.
Non-magnetic, right? If any kind of plastic I am giving you, it is magnetic or non-magnetic?
Non-magnetic.
Adrit, what about the iron? It is magnetic or non-magnetic?
Ma'am, like sometimes magnetic and sometimes non-magnetic.
Iron, nickel, cobalt, all these are like, the magnetic, they have the magnetic property depending on the kind of the magnetism what we are using for. So observe that magnets have two sides, north and south. Then third one, predict the motion of magnets. So how do they move? Based on the knowledge that they repel and attract. So depending upon the knowledge, we should know how why they are repelling, why they are attracting. Apply the process of identifying main idea and supporting details to show how the force of magnetism work and how it can be useful in everyday life. So how this magnetism or the magnets are very important for us in our day-to-day life. So that we'll be studying and classifying the object as a magnetic and non-magnetic. So the same thing. So history of magnets. So Shepherd was there. Hello, I'm Magnus. We live in Magnesia, which is a village in the northern Greece. So while grazing his sheep, what he got, he found that the Magnus found that the stick which he was carrying stuck to a black rock. So this is the black rock where his stick was getting stuck again and again. It got stuck. So the natural black rock having attractive property was thus named the magnetite. So this is what named as a magnetite. Magnetite. Therefore, the word has been derived from the magnetite. So magnetite has the word from this the magnet has come. So since it has a kind of the attracting property. Now, what magnets do? They attract certain material like the iron, steel, cobalt, nickel. So what the magnet they will be doing? They will be attracting the
Ma'am?
iron. Yes.
But many times, like I tried to attract magnets with steel, but it did not.
See, steel is not, same variety. It depends upon the steel has what kind of component. Every steel will not get attracted.
Ma'am,
That
like
is why,
stainless steel won't attract.
no, it depends. In the stainless steel also, you have the, major, so many varieties. You might have seen at the home also. When you have, like,
Yes.
when you go to the kitchen, you have the different stainless steel, different color of different, hardness of it. So depending upon the steel, it shows a property.
Okay, ma'am.
So what properties do they exhibit? The first thing, they have two poles. As you can see, they have the south as well as they have the north pole. Like poles are called as the similar poles. And what do? They repel from each other. Whereas unlike poles, they are dissimilar poles. And what do? They attract each other. Fine. So same, they will be same, they will be repelling, and different or unsimilar, they will be attracting. So you can see in this picture also. Now what happened? Here also we have a knot, here also we have a knot. So what will happen? Either they will repel or they will attract.
Repel.
They will repel. Whereas the next one you can see, here we have the north pole, here we have south pole. So what do? They will be repelling or they will be attracting?
They'll be attracted.
They will be attracting. Now what happened? Why they do so? They do it because of the magnetic field which is being created around them. So always what happen around this magnets, there will be this structures like you can see the lines present there. So these are called as a magnetic field. So this magnetic field shows the power of the magnetism. If more magnetic fields are there, then more magnetism will be there. And if the less are there, less magnetic fields are there, then it will be less magnetism it will show. A second thing, when suspend freely, a magnet always points towards which direction they will be pointing out?
North.
North. Fine. As if we are leaving the magnet to move freely, what do? They start moving to the north direction. And this is what the magnetic fields are. You can see in the picture, north and south pole are there, and surrounding the north and south pole are what? They are the line like structures, and these are called magnetic field. So are we able to see these lines actually in real? No, right? So we are not able to see the magnetic field. We are just, we are able to see only the magnet, not the magnetic field which is created by the magnet. So the force of attraction around a magnet is called its magnetic field. So what they are the force of attraction which is around the magnet. So, can you tell me where will the force of attraction be more in a magnet? Center, both poles, or only one pole? Where it will be the much?
Ma'am, both poles.
Both poles. So on both the sides, what happened? The magnetism will be more. Okay, now if I have this magnet, okay, if I have this, now Adrit will be answering. If I have this magnet, Adrik, here I have the north, maybe here I have the south. Now, what I did is, instead of keeping the iron and the nickel to the north and the south, what I did, I just kept it here in the center. Iron, I have kept it in the center. Now, what happens? The magnetism will be more or less?
Ma'am, less.
Less. Okay. So, that's what we are talking about. The force of attraction will be more where on the sides, which is like on the north pole and the south pole. Whereas in the center, the magnetism will be there, but as compared to the north and the south, it will be little less. So, do magnet attract? So, the different items are given. So, whether they attract or not, if they attract, then they are magnetic. If not, then they are non-magnetic. So, this experiment, frequently we do actually. When we are small, we are just playing with a scale. The steel scale will be
Yes.
taking. And see, Rishit, you can see this is steel scale, right? This steel scale get attracted easily with the magnet, right?
Yes.
So it has a different type of, the material.
Okay.
So the pins also get attracted, or the needles also. So that is why, like you might have heard, like what happens? Those tailors, the tailors will be using the needles, right? They are very, very small in size, and once the needle fall down, are we able to get it soon?
No, ma'am.
No, right? We can't find the needle easily. So what the tailor they used to do, they will be keeping with them a magnet, a big piece of magnet they will be keeping, and if in case the needle fell down by mistakenly, what do? They just move that magnet above the ground so as to find the needle, and easily once the magnet comes in contact with the needle, that needle will be coming on the magnet. So that is what the tailors they
Yes.
do. They will be using this method to pick up the needle. So magnetic material, the material which are attracted towards a magnet, they are called as a magnetic material, and the non-magnetic, the materials which are not attracted towards a magnet, they are called as a non-magnetic materials. So here, if some of the examples are given, some are magnetic and some are non-magnetic. Now coming to the next one, shapes of magnet. So we have the different shapes of the magnet. Magnets come in different shapes. Some of the common shapes are the first one, south and the north pole. So this is what we called as the, you can see in this picture, this is called as a horseshoe shaped magnet. So why it is called as a horseshoe shaped magnet? Because it is like the shape of the horseshoe. That is why it is called as the horseshoe shaped
Yes.
magnet. The second one is the bar magnet. Since the structure is like the bar, that is why it is called as a bar magnet. The
Yes.
third one is the cylindrical magnet. So this cylindrical magnet is very like common. So generally we find this cylindrical magnet in the
Yes.
different instruments and all. And the last one is the ball-ended magnets. So somewhere
Ma'am, ma'am, and disc magnet is also there.
yeah, disc magnet is also there, but these are the most common type of the magnets.
Okay.
Okay, applications. What do you mean by applications? What is the meaning of applications?
That means in the things which we use magnets.
Okay, so in a very simple word, uses. Okay, so application means uses. So uses of magnets. So first one, used in doors of refrigerator and steel almirahs. Second one, magnets are used inside the TV, sound speakers, radios, and mobile phones. For making magnetic compass, also it is being used. ATM cards also have the strip of the magnet. Have you seen that the ATM
Magnetic strip.
cards?
Yes, ma'am.
Yeah, they will also have a straight magnetic strip.
I'm like
So
to
that
store information in them.
correct. Then separating metals from the garbage. So this picture you can see how the metals will be segregated with the help of the magnet. So they will be using the magnet, and the magnet they will be bringing on the dust or maybe the waste material, and whatever the metals will be there, that will be getting attracted towards the what, the magnet. So that is how they will be separating the metals from the garbage. Then magnets play an important role in the various devices, which can be a small toy or a heavy 100-ton device to pick up the heavy metals. So in the toys also we have, and so many machines also have the magnets in it. So this we will not be. So electromagnets now, magnets which are which are made by passing strong electric current. Now electromagnets, two words here we are using. When we talk about electro, here it means what? The electric current. And when we talk about the magnet, we know we are talking about the magnet. So the magnets which are made by passing the strong electric current, they are called as the electromagnets. The two things are being used in this process for the electromagnets to be made. The first thing is electric current and the second one are the magnets. So can a magnet lose its attractive property? Yes, it can actually. It can be destroyed. So how magnetic property can be destroyed? So if we want that magnet should not work, so heating, the best way is to heat them. Second one, hammering. So though, as I said, like if I broke that one piece into the 5 pieces, still the magnetism will work, but not as a good kind of attraction. But in the case of the hammering, what we will be doing, we will be beating it a lot into small powder pieces or the small pieces and all, so that it will lose its magnetic property. Then dropping several times. So it happens, right? So once, twice, thrice, 4 times, 5 times, 10 times, 100 times. So the more we drop it, the magnetism will keep on losing. So by dropping it so many times, the property of the magnetism can be lost. And then storing it in a improper way. So if you are storing in some place where maybe the temperature is so cold, so there also the property of the magnetism can be loosened. Now, what happens when we break a magnet into several pieces? So, as we have studied that, as I have told you also before, so when we break that magnet into several pieces, what happens? Pole gets separated, right? So both the poles will be like north and the pole, south pole will be getting separated. So earlier I had this piece. Here it was the north pole and here the south pole. Then what happened? I broke into 2 pieces. Now what happened? The each piece will have the north and each piece will have the south of it. So both the poles will get separated and each piece will have what? The like pole. And each piece will have the unlike pole also. So which means in a very clear way that each magnet or each piece of the magnet will have the north pole and the south pole as well. Fine. So if we break down the magnet, then each magnet piece will have the north and the south pole. Both will be present there. Thus, we say that even we break a magnet into several pieces, each piece of magnet will have 2 opposite poles. That is one north and that is one south pole. Clear?
Yes, ma'am.
Adrit, Anoop, Soumya?
Yes.
Okay. So that is what about the magnet is. So any doubt, if you have, you can ask, you can clarify your doubts. And children, turn on your video. I can see only Rishit and Adrit. Others also need to turn on the video. Okay, Anup. I think nowadays, like a lot of problem, I think on your like network part, because I also cannot hear you, your voice in a proper way. Earlier it was very audible, but nowadays it is not coming. I don't know why. Just get it rectified also. Okay, no. Yeah, I can hear you, but not so clearly. Maybe whatever the headset you are using, maybe that is the problem. You just find out, okay? You just find out because I am also not sure, but your voice is like again and again very low. Okay, children. Now I have uploaded a file under the
Yes, ma'am. I opened it.
resources. Open that Fun with Magnet Foundation. Open that file. Start doing level 1 questions. And then once it is done, we will be discussing the answers of those. Question number 1 to 10, first complete them. Then answers will be discussing. Then we'll be going to question number 11 to 20. And then at last, 21 to 30 questions. Anup, you need to start doing the foundation, Fun with Magnet Foundation. Open that file under the resources. Those level 1 questions you need to solve. Soumya, turn on your video also. Anup, when your paper starts, also just write in the chat when it starts and when it ends.
Ma'am, actually, I have to change screens, so my video has to be done.
Okay. The final exam paper in your school. Fifth Feb, it has started, means you are saying. 5th Feb or March? That's what I was thinking, March, right? Okay, okay. Okay, okay. Fine, all right. Start doing those questions now. Rishit, who is there? Rishit, on your video? Hmm. Once children, question 1 to 10 are done, let me know so that we can start discussing the answers for those.
Ma'am, we should not send it to you like on the WhatsApp.
No, 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 no. These answers we will be discussing then and there right now,
Okay.
as usual.
Done, ma'am.
Okay, Adrit. Anu, what are you typing for everyone? Done, Rishit, Anup, and Soumya?
Ma'am, last one.
Okay. Okay.
Done, ma'am.
So shall I share the screen?
Ma'am, everyone is completed.
Yeah, hopefully. Okay. Adit, start with the question number 1.
Yes, ma'am. Which of the following is a magnetic material? Ma'am, nickel.
Correct. So nickel is the magnetic material. Rishit, question number 2.
Yes, ma'am. The force that a magnet exerts on iron is called. Ma'am, is it option A, gravitational?
No. It is a frictional force. So the force which exert the pressure on the magnet or the iron, it is called as a frictional force. So we have studied that the fields will be there, the magnetic fields will be created. So why those are created? Those are created because of the friction only.
Okay.
So the answer is frictional force.
Frictional force.
Anoop, answer number 3rd. Read the question and say the answer.
Actually, I'm not clear with that.
So you will be going for the question number 4 in that case?
Yeah, ma'am.
Okay.
A magnet has 2 poles.
Okay. The magnet has 2 poles. So may I go with the question number 3?
Yes, ma'am. Unlike poles and dash
No.
and
Question
like
number 3.
pole,
Question number 3.
magnetic is made of mainly a chemical called ma'am, is it C?
No. It is a B. So I'll tell you, magnetite is made. Magnetite is the black color material, the black color mineral is called as magnetite. So the magnetite is made of mainly a chemical known as the iron oxide. Okay. So whatever the question comes related to the magnet, if they ask you to write what they are made up of, so always keep in mind they will have what? They will have the iron in it. Okay. So iron oxide is the correct answer. Okay. Adrit, question number 5.
Yes, ma'am. Unlike poles dash and like poles dash each other. Ma'am, attract and repel.
Correct. So unlike poles will be attract, and like poles repel each other. Correct. Rishit, question number 6.
Yes, ma'am. A freely suspended magnet comes to rest in the dash direction. Ma'am, is it option A?
Correct. So what happens if we leave the magnet freely suspended? Then it starts moving in the north-south direction. Question number 7, Soumya.
Yes, ma'am. The substances that are attracted by a magnet are magnetic substances. These,
Correct.
ma'am.
So they are called as the magnetic substances. So the substances that are attracted by a magnet, they are called as the magnetic substances. Good. Okay, Anup, question number 8.
Yes, ma'am. Okay. The instrument which is used to identify geographical directions. Magnetic compass.
Correct. So it is called as the magnetic compass. Good. Question number 9, Adrit.
Yes, ma'am. Which of the following is used to identify north direction? Ma'am, C.
Correct. So magnetic compass is used to identify the north direction. Good. Question number 10, Rishit.
Yes, ma'am. A magnet can induce magnetism in. Ma'am, is it option D? Iron.
Correct. Fine. So iron. Now understood. Wherever you have the question related to the magnet, it should contain the iron or iron oxide.
Yes.
Okay. Now start doing question number 11 to 20, and then we will be discussing the answers for those.
Ma'am, I'm done.
Okay.
Ma'am, done.
Okay. So we should start discussing now. So Swami, you need to start with the question number 11.
Yes, ma'am. A small piece of dash ore is called a magnet. Ma'am, iron.
Okay. A small piece of iron ore is called a magnet. Good. Question number 12, Anu.
Yes, ma'am. Ma'am, no. Which magnet is used in compass? Ma'am, I wrote as bar magnet.
It is magnetic needle. Okay. So you might have seen the magnet compass, and in the magnetic compass, a needle kind of thing will be there. So that's the answer. The magnetic needle, to identify the direction of it. Question number 13, Adrit.
Yes, ma'am. Heating a magnet leads to, ma'am, both A and B.
Heating a magnet.
No, ma'am.
No.
It's here.
Heating a magnet lead to the demagnetization.
Magnetism.
So heating will not increase the magnetic strength. Increasing magnetic strength means it will become more magnetic. It has the power will increase. The magnetism, the power will increase. So that is why the answer is A. So heating a magnet leads to the demagnetization. Okay, question number 14. Rishit.
Yes, ma'am. The electromagnets used to make electric doorbells are, ma'am, is it option B?
Option A. So in the electromagnets used to make the electric doorbells, what do they have? They have the horseshoe magnets in it.
Yes.
Question number 15, Soumya.
Yes, ma'am. The force by which objects tend to push each other is called repulsion.
Correct. So the force by which the object will be tending to push each other. Question number 16, Anu. Anup, question number 16. Is he there?
Ma'am, I think he's in mute.
Just 1 minute. Okay. Okay, we can go for the next child. Yeah, Adrit, answer for the question number 13. Sorry, question number 16.
The magnetic north pole of the earth is near the, ma'am, is it B?
Correct. So the magnetic north pole should be where? Should be near the geographical south
Geographical.
pole. And if I talk about the magnetic south pole, it will be Where? It will be near to the
North Pole.
geographical North Pole.
Yes, ma'am.
Fine. Okay. Question number 17, Rishit.
Yes, ma'am. In a bar magnet, magnetic strength is, ma'am, is it option A, more at both ends of the magnet?
Yes.
Yes.
Yes. More at both ends of the magnet. Question number 19, Soumya.
Yes, ma'am. The end of a magnet which points towards geographic north is called.
Ma'am, question number 18.
18. Okay, fine. 18, yes, 18. Which of the following is not a magnetic material, Soumya?
Yes, ma'am. Cobalt.
Correct. So the cobalt is not the magnetic material.
Ma'am,
Or copper.
yes, ma'am, copper.
Cobalt is the magnetic
Ma'am,
material.
actually,
Iron is the
cobalt
magnetic.
is a
Hmm.
magnetic material.
Yes, iron is a magnetic material. Cobalt is a magnetic material. Nickel is a magnetic material.
Iron,
But
nickel, and cobalt.
copper is not the magnetic material. So hence the answer is copper. Copper is a non-magnetic material. 19, Adrit.
Yes, ma'am. The end of the magnet which points towards geographic north is called dash poles, whereas the end of the magnet which points towards geographic south is called dash pole. Ma'am, option B.
Again, read the statement. Uh, what here? Here, what they are saying, the end of the magnet which points towards the geographic north. They are talking about the pointing. They are not about the nearby. Okay. So what it should be? It should called as the north pole.
North.
Whereas the end of the magnet which points towards the geographic south is called as a south pole. In the question, they are not asking that which pole is present near. Okay, near to the which pole. Okay. Here they are asking the point, which is called as what?
Yes,
So
ma'am, yes, ma'am.
north will be called as north and south will be called as the south only. Okay, Rishit, question number 20.
Yes, ma'am. Which of the following instruments use magnet? Ma'am, all of these.
Correct. So tape recorder, microphones, ATM cards, they all will be using what? The magnets. Okay, go for the question number 21 to 30 now.
Ma'am, done.
So soon?
Ma'am, like before only I completed till 27th question.
Okay. Shall we start now? Adrit. So now we need to start with the question number 21. Okay. Rishit, start with the question number 21.
Yes, ma'am. Force by which objects tend to pull each other is called, ma'am, attraction.
Correct. It's called as attraction. So, Amya, question number 22.
Yes, ma'am. The magnetic south pole of the Earth is near the ma'am, A.
Correct. So, the south pole of the earth will be near to what? The geographical north pole. So, the answer is A.
Yes, ma'am.
Question number 23. Adrit.
Yes, ma'am. Magnetite is, ma'am, B, a natural magnet.
Correct. So, magnetite is a natural magnet.
Yes, ma'am.
24. Rishit.
Yes, ma'am. The phenomenon of the attraction of a substance by a magnet is called, ma'am, is it magnetism?
Correct. So, it is called as a magnetism. The phenomenon of the attraction of a substance by a magnet is called as a magnetism. Question number 25, Soumya.
Yes, ma'am. Artificial magnets can be made by both B and C, ma'am.
Correct. So, by using the mechanical method and also by using the electrical methods, we can
Ma'am, we
make the
can make
artificial.
using chemical methods also, no?
No, magnets cannot be made by chemical, by using the chemicals.
Okay, ma'am.
Question number 26, Adrit.
Yes, ma'am. In ancient times, humans made navigational compass by using, ma'am, lodestone.
Correct. So by using the lodestone, they used to make the navigational compass.
Yes,
Question number 27, Rishit.
parts of the magnet where attraction and repulsion is maximum called, ma'am, is it option A? Pole.
Correct. The poles. So at the poles, what happened? The attraction and repulsion will be maximum. Question number 28, Soumya.
Yes, ma'am. Which of the following of a magnet are used in navigation? Ma'am, directional property.
Correct. So as the word says, so in the word itself, it is given direction, right? So for navigation also means for direction. So if you want to like if when you want to go somewhere, what do? You will be navigating the place, right? You will be navigating using the Google, what is the name of that app? Google Map,
Google.
right? Google Map. So by using the Google Map, you will be navigating the path, the direction of it. Same way, they used to have the directional property for navigating. Question number 29, Adrit.
Yes, ma'am. Magnetic force is a muscular force.
Magnetic force is a muscular force.
Ma'am, I think it's contact force.
It is a non-contact force. Okay, it is not a muscular
Okay.
force. It is a non-contact force because the north and the south pole. Are you able to come in contact with that?
No, ma'am,
No,
no. Ma'am.
right? No. Question number 30,
Yes,
Rishit.
ma'am. Steel is an alloy of, ma'am, all of these.
Steel is an alloy of all of these. No, steel is an alloy
Aluminium?
of iron. Okay,
Okay.
steel is an alloy of the iron. It does not have the aluminum, it does not have the cobalt, it has only the iron.
Okay.
Okay, now children start doing the level 2 questions, question number 31 to 40.
Okay.
And children, today just learn this chapter, okay? So tomorrow we will be starting with the subjective part. So learn this chapter so that tomorrow you can write the answers on your own.
Ma'am, I have a doubt.
Yeah, tell me.
What do you mean by Sar's test of magnetization?
Wait. Which question number you're talking about?
32.
Okay. Question number 32, it states that by which kind of test it is surest. Okay, sure. How you will be sure about this? Okay, that is what the surest. So, dash is the surest test of magnetization. So, if you want to check whether the particular thing is attracting or not attracting, or it is working as a magnet or not, so what kind of test should be done
Ma'am,
for it?
attraction.
Repulsion test.
Okay.
Okay, so repulsion test is the surest test of the magnetization. So, to check whether it is working or not working. So if it is attracting, definitely we'll be knowing, right? It is a magnet. So we have to check over the property which is not working.
Yes, sir.
So we will be doing the repulsion test.
Ma'am, I cannot understand the third one. Like 33.
Hmm. 33, just let me open the question. Okay. 33. Which of the following gets demagnetized when a powerful magnet is kept near to it? Okay. So these things are they have given. They have given a compact disc and they have given the cell phone. Okay. These two things are given. Now they have asking you if you keep either the compact disc in front of the magnet with magnet or the cell phone with magnet, then the demagnetize will be happening or not. So how the demagnetize will be happening with this two, it will happen or not? So the answer is what? C. So both of them will get demagnetized if we keep any kind of powerful magnet with them. So they will not, the kind of magnet which is present inside them, they will not work. So that is why if cell phone you are keeping near the magnet, powerful magnet, the cell phone will stop working for some time.
Yes, ma'am.
Done, ma'am.
Okay. Fine, children. So these answers we'll be discussing in tomorrow's class. At the same time, we will be doing the question number 41 to 50 also tomorrow in the class. And if it is not done, 31 to 40, kindly do it as a homework and make sure that you learn this chapter so that tomorrow when you come, you should be well prepared for the subjective test. So subjective questions will be practicing. You will be writing the answers. Then and there I'll be checking in the class. Okay. And Adrit, after this, which chapter do we need to revise?
Ma'am, motions of measurement.
Okay. Fine. Motion. Okay, fine. Okay. We'll do that. Okay. Okay, children then.
Okay, ma'am.
Okay.
Thank you, ma'am. Bye, ma'am.
Thank you. Bye bye.